Welcome, everyone. This is amazing to see packed room. Thank you all for joining us. Really excited to introduce OpenCost today. So quick rundown of agenda. Chris is going to talk a little bit about the very dynamic and rapidly changing Kubernetes market. We're going to introduce the new OpenCost project. And then we're going to talk about some of the kind of methodologies, principles that are at play there, and as well as some of the lessons and best practices that you can take back to your FinOps practice today. So my name is Webb Brown. I am co-founder and CEO of Kubecost. We built FinOps solutions specifically for Kubernetes and containers. I was previously a Google PM working on infrastructure monitoring. I am very proud to be joined by Chris, CTO of CNCF, and all-knowing about all things cloud native.
Of course, yeah. You got the clicker? Cool, we'll go next. So honored to kind of be here. I'm actually so happy that the FinOps X conference is happening because, for those of you who don't know, I helped kind of bring in the FinOps Foundation into the Linux Foundation. It's kind of a sister foundation, and I was always pushing JR, like, do something in person, do it. You have a great community, and here we are today, so super stoked to be here. So, I'm assuming most folks in this room have heard of Kubernetes, yes? Maybe potentially use it in your how many people use it in their organization? Raise your hand. Okay, that's a good, I'll like 60, 70%, maybe a little bit higher. So it should be to no surprise to you that, Kubernetes has kind of just become the de facto container orchestrator solution, out there. I don't think it's a question of, should you use Kubernetes, and more of like how you actually should go about using it, which is a lot of focus on. But we have done a lot of studies and numbers. It's a very unique project where every public-private cloud in the world has Kubernetes as a service now. It has basically entrenched, almost any organization out there that is using any, kind of cloud or multi-cloud solution generally has Kubernetes behind the scenes. In terms of growth, we've commissioned some studies. There are a little bit over, from independent research, there are over 7 million cloud native developers, out there, which is quite a large number overall. The CNCF, the organization that I helped start and run, we host over 130 projects. There's 160,000, contributors from a bunch of different countries all over, making this software into something better every day, essentially. The other kind of interesting thing is you're going to see more Kubernetes and cloud native in the future, because what's happening with Kubernetes is kind of something similar that would happen with Linux. If you remember Linux in the early days, how, fun little hobbyist operating system, created by Linus, people started to stuff Linux into embedded devices in mobile phones, in automobiles. It took over the server market. Kubernetes is going through a similar evolutionary cycle where, Kubernetes was built to manage massive scale workloads across multiple data centers. Well, what's happening now is people are now, saying, why can't I use the same orchestration technology to scale and manage edge-based, workloads, right? And so people are starting to modify Kubernetes to run on smaller environments and so on, just to reuse a lot of that technology in a new environment. It's the same thing that happened in Linux. People hacked the living hell of it to, make it work in different environments. Same evolution is happening in Kubernetes. So you'll see this core intelligent orchestrator and all the software around it in more and more spaces and industries. We recently hosted a KubeCon not so long ago, and I'm finding out like, someone's, using Kubernetes to manage, satellites in space and stuff. I'm like, these people are just crazy. But that's naturally what happens with like any open source software that is widely adopted and potentially applicable in other sense. So I don't want to waste too much time outside of like Kubernetes is everywhere essentially, and can continue to expand its reach, and see if the clicker actually wants to work. Yes. So the other interesting thing about Kubernetes in general is it's a lot more dynamic when it comes to the resources that it manages. Definitely a lot different than your kind of historic statically partitioned data centers and services. Kubernetes by natural, everything is extremely dynamic. So you have services, pods, containers, things come and go. And so when you basically share more resources and things in a more dynamic environment, it changes kind of the game of how you do measurement of costs, how you actually, work with the software, especially across multiple, clouds. So things, I think are evolving, and Webb is going to speak to this in a bit. You kind of have to rethink, your FinOps practices in a Kubernetes environment. And I think what you're going to see is, we're all going to learn from each other in terms of, how things have been done currently in FinOps and how to kind of do it in a very dynamic, scalable environment. Because, by default, Kubernetes has many different ways to scale resources, different autoscalers, setting requests and limits are not necessarily easy by default, right sizing things. So just a kind of different environment. I think, we're all going to learn together and make this easier across the industry, because historically, not many organizations truly cared about this problem. And I think here today at this event, you're seeing a lot more people getting together to actually improve things. So I'll hand it off to Webb to talk a little bit about the, OpenCost project and kind of where things are evolving there. So.
Awesome. Thank you so much, Chris. Amazing overview of just how rapidly Kubernetes is being adopted, but also how it's forcing us to kind of rethink some of the application of FinOps. A lot of these are principles that have been around for a while, but totally new abstractions. Again, much more dynamic. Pretty much everything is typically shared in most common deployments of Kubernetes, et cetera. So I could not be more excited to introduce the OpenCost project. This is the first live talk about it. It was just introduced 2 weeks ago. The goal is to now give an overview of the project, as well as, again, share some actual lessons that we've learned while building it, but also while working with thousands of companies running Kubernetes over the last 3 or so years. So let's dive in, and let's first talk about what in the world is OpenCost. So it is a brand new, pure open source implementation of Kubernetes cost monitoring and cost allocation. So ultimately, this is aimed to give you, real-time, highly granular, and very accurate cost visibility in any Kubernetes environment. And we believe that this is the critical and often missing foundation of a great FinOps practice in Kubernetes and containers ecosystem. In fact, a CNCF survey last year showed that about 70% of organizations running Kubernetes were missing accurate visibility in their Kubernetes footprint. So the OpenCost project itself actually has 2 components. One, a brand new community-built spec that was just released about 2 weeks ago. It is vendor-agnostic. It's Apache 2 license, and totally open for contribution today.
And as of last week, entered the CNCF sandbox, so it is part of the CNCF.
Yeah, so really proud to announce exactly that just got accepted to CNCF as a sandbox project, and we are going through as a community onboarding for that today. And then the second piece of this is an actual Go software implementation of the spec and all of its requirements, which was originally the core Kubecost cost allocation engine. So that today supports AWS, Azure, GCP, and on-prem clusters out of the box. So a little bit of backstory on the project. I want to quickly talk about the origins. This amazing group of contributors has been working really hard over the last 4 to 5 months to build the core spec. It is, as you can see, a group of cloud providers that were hearing about this problem from their end users. It is end users themselves that have been running Kubernetes at massive scale for years. And then lastly, it is like Kubernetes experts, those building observability solutions in the Kubernetes space or applying FinOps to Kubernetes users. So this group again has been working on this for 4 to 5 months. So it's super cool to see it now begin the onboarding phase and enter the CNCF ecosystem and have a neutral home where others can contribute to the implementation as well as the spec. And then also start to think about integrating on top of it, in various forms. And And it's really interesting to think about this backstory, how this came together. It was largely organic in the sense that, again, a lot of these users had seen various implementations of cost monitoring in Kubernetes before. And because there's really no source of truth from your cloud provider, there were 20 plus, if not more implementations and ultimate actual numbers that teams arrived at. So it was really interesting to see everybody see a very natural opportunity to come together and create a common language here, so that when we say the cost of a namespace or pod, et cetera, that we all agree on kind of the methodology and how we got there. Cool. So let's talk about some of these like core tenets and principles that are at play here. And I'll just point out that all of these are geared towards ultimately enabling teams to actually act on this information, right? That's super important to kind of our mission, and everything we've done and thought about in our design was based on that principle. So first and foremost is the ability to break down costs by any dimension. So that is go all the way down to the container or pod level and get super granular, and also go all the way up to the entire cluster level and think about a macro picture and really be able to do everything in between, right? So namespace, label, annotation, controller, service, you name it. We haven't seen an aggregation of data that we don't support yet, but if you have one, let us know. So this is super important for two reasons. One is that organizations architect applications, and because of all the flexibility of Kubernetes, think about costs differently, right? So like you actually have to support a wide range to give a real flexible view into costs across organizations. But then secondly is, and we've heard this conversation many times, is you bring a figure for the cost of a namespace or a service to an engineering team, and they say, well, where in the world did this number come from, right? And the ability to answer that it's super critical to essentially be able to dig in, right? So this label or this namespace contains these deployments, these stateful sets, these jobs. Okay, well, this deployment contains these pods, these containers, et cetera. Again, you can drill all the way down to actually see what's driving costs across any resource in your environment. Secondly, you have the ability to do this in real time, which when you think about like a common FinOps reporting practice, it seems maybe excessive or unnecessary. We actually think that this is going to become increasingly critical when you think about, again, taking action. And that's because you're seeing more configuration of auto scaling and more, again, really dynamic deployments of different jobs, pods, et cetera. And having this information in real time allows you to have really interesting new use case and actually base some of those scheduling, like configuration decisions on costs at the time. And then secondly, because the project itself actually uses usage as well as the state of your Kubernetes environment, this real-time sampling allows you to have accuracy, right? It allows your engineers to feel confident that this is based on real data in their environment. So third, because this is purpose-built from Kubernetes for Kubernetes, we would naturally allow you to share all these resources based on different allocations, right? So that's the underlying assets is what, nodes, load balancers, disk, et cetera, but it's also, the resources that are in your environment that may be shared across other tenants. So maybe you have a monitoring namespace or a logging set of tools or system files that are shared across resources. The spec and the implementation supports distributing those in different mechanisms. And really interesting is that, this requires no backing cloud tagging to have all of these things. So this fits with kind of the native Kubernetes organization of workloads, whether that's by namespace, by service, by controller, et cetera. So we've found that it's much easier to actually coordinate and assign, for showback, chargeback, et cetera, because you're not requiring on kind of backing, manual tagging, if you will. And like I mentioned, we've got direct billing integration for AWS, Azure, GCP in the project today. So that would go and pull real-time billing prices from those providers. And then you can bring essentially like a custom pricing sheet for on-prem Kubernetes clusters when you determine essentially the operating cost of all of these resources in your environment. And so again, all of these build up to a project that is aimed, like purpose built to be actionable for engineering teams and FinOps teams. And one really important part about this being open is it allows it to be interoperable with a lot of other tooling in the Kubernetes ecosystem, right? So supporting open telemetry, working with projects like Prometheus and Cortex and a bunch of others allows you to bring this data to your Grafana dashboard if that's where you look at observability metrics, right? Or to the kubectl CLI if that's where you spend most of your time. So we view this as again, these open standards as the ability to bring this data a lot of other interesting places just to bake it into your workflow as an engineering and FinOps organization. All right, so let's talk about how this model actually works. When we talk about like all the complexity of Kubernetes, it's really just two equations we're actually solving, two simple equations. The first is, what is the cost of a cluster? And the way we do that is we look at, in the model, we look at all observable cluster costs. So compute, storage, networking, everything that is observable from within a cluster. And then we break it down into direct asset costs. You can think of as kind of like COGS or variable costs. And then overhead costs, which are more like SG&A and fixed costs. And we'll talk about some examples of those shortly. And then lastly, asset costs can be further bifurcated between fixed allocation cost and usage-based cost. So allocation costs are situations where you're actually kind of paying to provision or reserve capacity. Usage-based costs are where you're actually just paying for what you use. So if we look at just a couple quick examples of these, at the bottom, you'll see just an example of overhead costs, right? So cluster management fees that you may be paying to a cloud provider. On the left, we've got some like allocation-based costs, so like nodes and all their individual resources, so CPU, RAM, GPU, et cetera. Again, you're provisioning these, and you as a resource or as an organization are paying for these resources, even if you're not using them. And then again, a common example of purely usage-based in a Kubernetes environment is just network egress costs, right? So this ultimately will allow you to dictate the cost of an entire cluster that you're running. Oh, sorry about that. All right, now let's flip over to the other side of this equation and think about applying the costs of these clusters to workloads, right? So on the left, we have the same frame that we just looked at. So direct costs being broken down by allocation costs, usage costs. These can then be applied to workloads. And specifically, the allocation costs are either actually allocated to some job or workload doing something in your environment, or they're just purely cluster idle, right? So, now that we have this equation, we have everything we can think about cost in every dimension, right? Well, actually, there's one really big missing piece, which is like, well, how do you actually determine the cost of workloads? And that is, again, for a usage-based model is very simple. You pay for what you use. You think about a byte of egress on your network. You allocate that back to a pod, job, et cetera. But for allocation, it's a little bit more complex, and this is the last missing piece of that. Specifically, the model looks at both a usage mechanism as well as a request or reservation mechanism. So we've got a couple examples here. On the left is a pod that is deemed best efforts because it does not have a Kubernetes request or limit. By that, it means the scheduler is not allocating resources for it per se, and it only kind of gets what's available, right? So if nothing's available, it's going to be the first one to be throttled, out of memory, evicted, et cetera. And so here, in this case, because this resource is not actually request anything, it'll just get paid or billed for what it's actually using, right? So that's actually a really interesting and good thing from a cost perspective, but it comes with a quality of service trade-off. Again, there may be no resources available for it. So from a cost efficiency standpoint, it is maxed out, if you will, but from a reliability standpoint, it's actually really low on the scale. Then in the middle here, we've got an example where there is a request set, but this request is set above usage. So you would have some notion of idleness available. So this, from a cost efficiency standpoint, would be lower than the best efforts example we just went through. But it would actually, quote, like guarantee to a certain extent resources are available for this workload. So here, again, we'd be looking at the max of requests and usage. So given that this resource has requested more than it's using, it would get billed its actual request. And again, that's really important for a number of reasons. One is that even if this workload is not using this resource, it's not available to anybody else in the environment. So it's provisioned and kind of allocated. It should be billed. And then secondly is it kind of avoids the situation where teams try to kind of game the system and not set requests or set requests in a funny way. And then the last one is actually very similar. It's where there's actually a limit that is above the request. This is basically so that you can't burst above this actual limit. The point here is that limits are not actually taken into account. You can think about this as kind of like a limit on your credit card. It's the maximum that you can spend, but it's not necessarily what you're actually spending. All right, so let's talk quickly about some of the lessons that we've learned, again, from the time building this model, but also the years working on Kubernetes cost monitoring. And the first is just this really critical, like cost by a bunch of different dimensions is super valuable for actually taking action. Again, the ability to drill down all the way to the pod level, like we just saw, allows you to have high confidence and really be specific about your intention in terms of how you manage costs, whether that's setting requests, whether that's thinking about auto scaling, whether that's thinking about tuning a deployment in terms of how it scales replicas, whether it's the amount of resources that a particular pod is using across CPU, GPU, et cetera. All these insights become available when you can start from a really broad macro showback or chargeback picture and then drill all the way down and see the why this cost is what it is. And then second, again, already starting to see really interesting use cases from this real-time nature of costs. And again, you think about this as like a scaling or setting quotas or budgets or policies in real time when a set of workloads scales up or is deployed. And so it's less of the reacting maybe to bill shock the day after or later that day, and then more setting your optimization trade-offs across reliability and performance and cost in real time. And again, we've just found that coming from a world previously of thinking about cloud tagging a lot, it is really nice to be able to leverage your kind of natural developer workflow and benefit from kind of the natural segmentation, if you will, of what kind of Kubernetes forces you, of like you have to be in a namespace, right? And then for things that are optional like labels or annotations, you can actually use policy like OPA and others to make it so this is a gating requirement before a workload is actually deployed. And so I would then kind of touch on one really last insight we've found from our years of doing this, which is if you get this visibility in place or any visibility in place, we think the best metric for a starting point in thinking about kind of optimizations is this notion of cluster cost efficiency. And what that was just the delta between those workload usage cost and the actual total cost of a cluster. And again, because OpenCost has built that model up from individual containers all the way up and from a cluster down, you can get a really accurate snapshot of that. And it is not uncommon at all for us to start working with teams and see that they're in like single digit or low double digit cost efficiency. And that can typically be scaled or grown really, really rapidly once you get this visibility in place. So with that, we can have a couple minutes for Q&A. I think we've got right about 5 minutes or so.
Yeah, that was pretty good. You guys are right on time.
Cool.
Sweet.
For questions. Okay.
Yeah, so thanks, guys, and we'll take questions. We have about 5 minutes, so if there's questions. Yeah. I will allocate them out.
So the question's easy. In the cost allocations, do you use limits as one of the factors to allocate costs?
Yeah, so it is not part of the core cost allocation. So we're purely looking at the max of requests and usage. And there we're saying that's what's actually been used for your workload. Whereas again, the limit is like, yes, that's what you can burst up to. You may never touch it. And it's actually available. The delta between the rest of the request limit is actually available to other tenants. So you should.
Do you think that would be valuable in the future as a third metric to do the comparison out?
We've actually had a good bit of discussion about it, and I would say discussion ongoing, and we'd welcome you to the working group if you want to discuss it. But yeah, absolutely, we've definitely talked about it.
Question. How do you collect the metrics for some of the usage? Do you have an agent that you need to deploy?
Great question. So the OpenCost, like a pure open source deployment, is a single pod, and it by default takes a Prometheus service address. So you can piggyback and again, like use all your C advisor and other metrics you're already collecting. And that again, we see it as like one of the real benefits as part of CNCF as being just super closely aligned with OpenTelemetry and all these. So yeah, it's very much like designed to really integrate with an existing observability stack. It can be deployed with a separate, like Prometheus, et cetera.
Have you think of a way to integrate the Kubecost into the general kind of a cost management reporting? Because like having two different sources would be kind of a complex. So maybe you think of a standardized approach on like working with the other tools.
Yeah, absolutely. So I would say two things. One is starting to see our first integrations already. So teams taking the open source and actually integrating into their project. We'll be excited to share hopefully some really cool integration soon, and definitely want to encourage and do everything we can, and really excited to see kind of how that gets baked into different consoles or management solutions or FinOps observability. So that's one, and then two is the spec is designed so that if others want to implement it, they can just follow the requirements and build it into their core FinOps product without ever touching the open source as well. So it's just 0.1 now. So I would say just starting to have conversations about others actually implementing it just based on the spec. I expect it will evolve considerably in terms of getting easier, et cetera. But yeah, I think both of those ways will be critical for this coming to other products.
And I think one small thing you could do for us as a favor is, some of you have very, or are part of large organizations, have large cloud bills and work with, different cloud companies and other services. Push them to contribute to this effort. Like they're going to listen to their large customers instead of potentially, a vendor or a crazy person that runs a foundation. You, at the end of the day, are going to be able to have more influence. So please do that. And that's the only way I think this project is going to grow and get better over time. So we have less than a minute, so maybe time for one question before we close it out. Anyone else?
Pass the mic down. Question down here.
Oh, one more.
So this now kind of understands the idleness of the cluster. So what are the kind of strategies of allocating the, shall I say, idle compute that this supports, or what you kind of targeting in the design?
Yeah, so let me just make sure I have it right. So have the ability to allocate idle in this model. What are the various strategies for allocating it? All right, cool. Yeah, I would say there's a range, but I most commonly see two patterns. One is that it is distributed evenly across tenants. And you say kind of like, if you're part of our core platform, there's typically many tenants in this case, so you will be in and get your portion. The other is proportionate to how many resources you're actually consuming in the cluster. So that would be typically based on the actual cost of your workloads, distributed accordingly. So I would say those are most common when actually distributing them. Some teams do not distribute them because they say that their tenants actually have no influence to impact the size and dynamics of the cluster itself. So they just say, here's, you're paying for your compute, your resources, et cetera. So, and happy to talk more about that, but.
Thanks, Chris. Thanks, Webb. For everyone,
This is amazing.
round of
Thank you all.
applause.
JR here from the FinOps Foundation. Thank you for watching. Please go to FinOps.org if you want to get plugged into this amazing community. And of course, hit subscribe right here on YouTube to get all the future content. Hope to see you soon.